A large model Showman'S engine part 43, improving the passenger truck and fitting the motion guards. As this series draws towards its inevitable conclusion, I thought I'd save some of the worst jobs until last. Frankly, this passenger truck is not very well made. Parts of it are okay, the welding is diabolical, but it's obviously been used as a passenger truck, so I assume it's not too bad. But I really didn't like the pivot on the steering. So in the first part of this episode, I need to do something about that. You're watching me at the moment using a hand drill with a cone cutter to enlarge the hole in the passenger truck. I had to enlarge this hole from both ends because the width of the steps on the cone cutter were too shallow to get through in one. This job took quite a bit of doing, and I have a health and safety warning that is very important. When using this type of cone cutter in a hand drill, make sure that you do not use an extremely powerful hand drill. Otherwise, two things could happen. One is you could break your wrist, and the other one is something I did a few years ago, you can pull your back out. When I hurt my back, I was sat on a stool drilling 2 holes in the cab roof of a Sweet Pea locomotive, using my DeWalt drill in a low gear, and it's very powerful. The cutter caught up and the handle twisted round, and that in turn twisted my back round, and I was in agony for about a week. These days I think I must have got wiser because I'm using a less powerful drill, and I use a different technique when I use these hole cutters. I try and use my entire forearm and not just my wrist to absorb the shocks when the cutter locks up in the hole. Ordinarily though, I don't need to use a hole cutter in a hand drill, and I'm thankful for that because it's quite a difficult job. Eventually, I enlarged what was an M10 hole to 7/8 of an inch. Now it's back into the workshop for a bit of machining. This is a piece of close-grained cast iron. It's just a scrap piece, and the hole in the end of it is not in the centre, but for the moment that's not important. I'm reducing part of this cast iron to 7/8 of an inch, and I'm going to drill a hole down the centre, which will be 16mm in diameter to match the bolt that I have. Now I need to knock this centre hole into some sort of a shape. I'm using a large centre drill, which partly trues up the hole, but it's really not important for what I'm going to do with it. This is the bolt I'm going to use. I'm checking it with my micrometer, and it seems to measure 16mm. I assume it's 16mm because my micrometer is imperial, and it seems to be a bit bigger than 5/8 of an inch. And that's very convenient for me because I can drill the hole in the centre, which is not quite in the centre, using a 5/8 of an inch diameter drill bit. And to finish off the hole to 16mm, I'm going to use this very substantial boring tool. This will correct the lack of concentricity. Initially, to true up the hole, I took a very fine cut, and when I tried the bolt in place, it was a bit on the tight side. Ideally, this bolt needs to be a good fit, but not a tight fit. So I took another very fine cut down the hole using the boring tool, and after that the bolt fitted perfectly. Neither tight nor slack, just a perfect fit. That's the first part of the job. Now I need to split this piece of metal, but before I did that I turned it round in the chuck and machined the other side to 7/8 of an inch in diameter. After I'd split the part into two using a parting tool, I faced across the front of each of the parts. On one of the cast iron parts, I ground 2 flats, one at each side. I didn't bother using the milling machine as it's not a high precision item, and the job was completed very quickly using my 1-inch belt sander. To enlarge the hole in the moving part which supports the axle, I put the entire assembly in my drilling machine. As my drilling machine is floor standing, it was a very easy job to lower the table and clamp the part in the machine vise. And now there is a 7/8 of an inch diameter hole here as well. As I was making this, which is effectively a cast iron bearing, I estimated how thick it needed to be to clamp the parts together. Here's the principle. When it's all assembled, back down in the garage, I'm hoping that when I fit the parts together, these machined cast iron washers should meet in the middle. So it's down to the garage where the main passenger truck is to fit it all together. First of all, some grease. And to my surprise, when I bolted up the parts and fully tightened the bolt, the fit was perfect. At this stage I'd love to engage smug mode, but no, all I have to thank for this job is luck. Serendipity strikes again. Time to fit the wheels back on the axle. These wheels are fairly diabolical and the bearings have passed their best, to say the least. I'm pumping quite a lot of grease into the cavity between the bearings. That way at least I know there'll be some lubrication in there. Here I've refitted the washer and the R-clip. After this wheel I did exactly the same to the other three. So it's time to go back to the workshop and finish off the motion guards. The first part before fitting the guards is to polish up the brass using some Brasso. This is Brasso wadding. I'm sure this stuff used to be known as Duraglit, but anyway this is the Brasso version because it says so on the tin. All it is some wadding with a solvent that has an abrasive in it, and it's just the job for polishing up pieces of brass like this. The initial polishing was done on the polishing spindle because this brass was quite badly scratched. But now, after a quick rub with the cotton cloth, it's looking good. Time to put it all together. I'm using the countersunk screws with a washer and a nut behind. Once all of the nuts and washers were fitted, the motion guard was bolted to the engine and now it looks like this. The motion guard looks a bit naked. I think that's because it needs a nameplate on there. For the moment I'm going to move straight onto the other side. Once again cleaning up the brass with some Brasso and screwing the brass to the motion guard using these countersunk bolts. Have you noticed that I'm lining up the bolts so all the slots face in the same direction? You know what they say, if a job's worth doing, it's worth doing well. Well, in any case, I've done my best. And after the last nut and washer goes in place, it's time to fit it to the engine. Fitting the other side was not funny, it took ages. The flywheel was in the way, I couldn't get the holes to line up, etc, etc, but in the end I got there. Tomorrow, which is Tuesday the 4th of August, I'm taking the side panels from the canopy to a sign writer to have them sign written. I know exactly what I want on the canopy sides, but I think I'm going to rename this engine. It's currently known as Lord James, but that means nothing to me. I'm going to have to think what to call this engine, and there'll be a nameplate made to go on the motion guards, as well as one for the front. On a lot of Showman'S engines, the motion guards have the logo with the ring and the star, but this engine already has the star on the belly tank. Plus the cutout for the check valves at each side means I can't really put a big round brass bit in the middle, unless I cut part of it away to match the slot. Anyway, I'll give it some thought while the side panels from the canopy are being sign written. The last episode of this series will be the next one. After the sign written boards come back from the sign writer, I'll steam it just outside the garage where it's going to live. And that is it for this episode. I'd just like to say, as always, stay safe, stay well. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.